In this video, we are using integration with our functions of time. Let's look at the first question. A particle moves in a straight line. The velocity v meters per second at time t seconds is v equals 2t minus t squared. At t equals 0, the particle is at the point where x, which is the displacement, equals 5. So x is the displacement. Find an expression for the displacement of the particle. So when we went from displacement to velocity, we differentiated. Velocity is the rate of change of the displacement. So if we want to go backwards, the opposite of differentiation is integration. So the displacement, which we're going to call x, is the integral of the velocity with respect to time. So it's going to be the integral of 2t minus t squared with respect to time. When we're integrating, we add 1 to the power, divide by the new power. So t becomes t squared. 2t squared over 2 is just t squared. The power for the t squared becomes cubed. Divide by the 3. So it's going to be 1/3 t cubed. And we're going to plus c. That's why we've been given this information. So when t is 0, the displacement is 5. So when t is 0, x is equal to c, because we've got 0 squared, which is 0, minus 1/3 of 0 cubed, which is 0. So x equals c, and x is 5, so c is 5. So x is t squared minus 1/3 of t cubed plus 5. So that is our displacement. One question for you to try. Give it a go. A particle moves in a straight line. The velocity, v meters per second, at time t seconds is 6t squared plus 8t. When t equals 0, the displacement is 10. Find an expression for the displacement of the particle. So again, we're going from velocity back to displacement. We're integrating. So we're going to have the displacement is the integral of the velocity with respect to t. So add 1 to the power, divide by the new power. That'll be 2t cubed plus 4t squared plus c. When t is 0, the displacement is 10. So that's going to be c. So it's going to be x equals 2t cubed plus 4t squared plus 10. And that is our expression for displacement. A particle moves in a straight line. The acceleration at time t seconds is 4t minus 1 meters per second squared. When t equals 0, v equals 4, find an expression for the velocity. So just the same, when we had velocity and we wanted to find acceleration, we differentiate. Acceleration is the rate of change of the velocity. If we want to go backwards, the opposite of differentiation is integration. So the velocity is the integral of the acceleration with respect to time. So it's the integral of 4t minus 1 with respect to time. Add 1 to the power, divide by the new power. So that would be 2t squared minus t plus c. When t equals 0, v equals 4. So 4 is equal to 0 plus c. C is 4. So v equals 2t squared minus t plus 4. And one for you to try. Give it a go. So we're looking for the velocity, and it's going to be the integral of the acceleration with respect to time. So add 1 to the power, divide by the new power. and plus c. When t is 0, v is 5, so c must be 5. So the velocity is t squared plus 3t plus 5 meters per second. And another question. A particle moves in a straight line. The acceleration at t seconds is 2t minus 4 meters per second squared. When t equals 0, v equals 3, and we need to find the distance between the 2 points, the particle is instantaneously at rest. So remember, instantaneously at rest means the velocity is 0. So we're going to go from acceleration to velocity, and then we're going to have to find the distance. So we'll have to go from velocity to displacement as well. So the velocity is the integral of the acceleration of 2t minus 4 with respect to t. So add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and plus c. When t is 0, v equals 3. So c is 3. So there's the velocity. Where are the 2 points? It's instantaneously at rest. That's when the velocity is 0. So 0 equals, and I'm going to put this into brackets, it's t minus 3 times t minus 1. So it's instantaneously at rest at t equals 1 and at t equals 3. Now we need to know the distance between these 2 points. So where is it at t equals 3 and where is it at t equals 1? So we're going to have to know the displacement. So the displacement, we're going to integrate the velocity. So add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And I'm going to plus c, but it's not going to make a difference for this question because when we substitute in 1 and substitute in 3, they're both going to have a c. So the difference between them isn't actually going to make a difference. So I'm going to substitute in 1, substitute in 3, and look at the difference between my two answers. So that'll be the distance between the 2 points. So I'll just grab a calculator. So 1/3 of, we'll do 3 first, 3 cubed minus 2 times 3 squared plus 3 3's. So that's 0. So when t equals 3, the displacement is 0. So when t equals 3, s equals 0. And when t equals 1, what's the displacement? It is 4/3. So what's the difference between them? It is 4/3. So 4/3 meters. Okay, one for you to try. See if you can give it a go. So we have the acceleration, which is 2t minus 5. We know when t equals 0, the velocity is 4. We want to know the distance between the 2 points where it's instantaneously at rest, where v equals 0. We can find the velocity because it's the integral of the acceleration with respect to time. So that'd be 2t squared minus 5t plus c. When t equals 0, v equals 4. So 4 equals c. The velocity is t squared minus 5t plus 4. Where's it equal to 0? When t equals 1 and when t equals 4. They're the solutions to the quadratic. So make it equal to 0, solve the quadratic. Now we need to know the displacement. So velocity is the rate of change of the displacement. So that's differentiation. To go back, we integrate. So the displacement is the integral of t squared minus 5t plus 4 with respect to t. So add 1 to the power, divide by the new power. And again, I've got plus c here, but I'm not going to need it. I'm not going to need the plus c because it's the distance between the 2 points we care about. So the distance between when t is 1 and t is 4, if we substitute in 1, it'll be something plus c. If we substitute in 4, it'll be something plus c. So the difference between them, it won't be affected. So I'm going to substitute in 1, substitute in 4, and then look at the difference between them. So it's 1/3 of 1 cubed minus 5/2 times 1 squared plus 4 ones. And that is 11/6. So when t equals 1, the displacement is 11/6. When t is 4, I've got minus 8/3. So when t equals 4, the displacement is minus 8/3. So what's the distance between 11/6 and minus 8/3? 11/6 minus 8/3 is 9/2, or 4.5 meters.